Oracles are arguably one of the most important extensions built on top of blockchains when you actually start to think about how blockchains are going to replace real-world systems. And there's no more well-known oracle than Chainlink, so stick around and let's talk about it. Hey guys, I'm Sprague, and one big hurdle that needed to be overcome with crypto is that real-world programs rely on data that comes from external APIs and services. Unfortunately, these don't work on blockchains as they are closed systems, and therefore there's no way to actually make requests to these external web APIs. Due to the fact that blockchains have no external inputs or outputs, they can only work with data that is currently recorded to the chain. But before I get into Chainlink, if you do enjoy my content, please do consider hitting subscribe down below and potentially joining the Discord channel, links in the description. If your smart contract needed something as simple as the current price of ETH in dollars, you would have no way of finding that information out on chain without the use of an oracle. Using an example, let's say that you wanted to write a smart contract that replaces bookies. And for those in the US, a bookie is just a person that lets you bet on sporting events. This smart contract would take inputs of an amount of money and a team that the person is betting will win. Then, after the result of the match is determined, the money would be split between the people that placed a bet on the winning team. The problem lies in getting the information about what matches are being played, about the team info, and finally, the match scores. Without oracles, none of this data could be collected by a smart contract. This does mean that smart contracts are trustless, as they don't rely on the data of any external providers. But the problem with this is that when you introduce an oracle into the system, this brings back that dependency to trust a party again. The provider would have to be trusted enough that the data they are giving to the smart contract is secure, and that their systems will not be breached by a bad actor. However, Chainlink aims to mitigate this risk using aggregation contracts and a reputation system to make sure that the parties involved in their network are trustworthy. But before we get into any of that, the first Chainlink white paper was published in September 2017, with development starting in November 2017. Led by CEO Sergey Nazarov and CTO Steve Ellis, the project now has over 100 contributors, members, and advisors. Chainlink aims to provide smart contracts with the data they need to enforce an economically fairer global financial system. This means making sure that any system that we currently have in our traditional finance sector could be moved to the blockchain by giving that smart contract the data required to replicate its function. And I'll touch a bit more on the data aspect of things in a minute, but first we need to actually go into one of the second primary problems that blockchains have, which is randomness. Random numbers are generated using a seed, which in most programming languages is the time from the 1st of January 1970 in seconds. This, however, is a predictable way of making a seed, because you know if the number was generated after a certain time, that the random number generator is probably using seconds after that point and could potentially be brute forced. This level of predictability cannot be used in systems where the random number needs to be secure. Any number generated with this level of predictability couldn't be used in something like a gambling smart contract, because at the end of the day, someone could reverse engineer it and find out what their seed generation is. And the problem is that generating randomness in any technological environment is incredibly hard. For example, the DNS company Cloudflare actually uses a wall of lava lamps and a camera that takes periodic photos of that wall and converts it into a digital image to make sure that it is truly random. This complexity is then compounded by the fact that a number generated on a single node isn't deterministic. That is to say that when the smart contract is passed onto another node and rerun, the number generated would not be the same. Any random number generated on a blockchain needs to be verifiable, so that the number can be generated once and then used across multiple nodes. For this reason, using a seed like the time wouldn't work, because each node would end up generating its own new number. This was initially solved using off-chain solutions. For example, a smart contract would make a request to an oracle. The oracle would then process and generate a random number off-chain and submit it back to the chain via block info for use by any nodes that require it. This unfortunately has a major issue, which is that the random number generated is not verifiable. This means that in theory, the number could have been manipulated by the oracle to skew their favor in the smart contract that requires it. Or it could have been generated in a non-cryptographically secure way, which actually means that future numbers could be predicted. This is where Chainlink VRF comes in, which allows smart contracts to make requests using a seed to the Chainlink network and receive a random number in response. The seed submitted to the Chainlink network should be made up of pseudo-random elements. For example, the current hash of the block and the current price of Bitcoin provided by an oracle. The VRF will then mix this seed with some extra random data just to ensure unpredictability and then pass it along for random number generation. The random number is then generated by an oracle using a newly generated public key for that oracle and the seed that was provided by the smart contract. This means that when that random number is being used, it can be verified against the public key that was provided for it, which gives smart contract developers the assurance that that number has not been tampered or modified in any way through transmission across the blockchain. But the main reason that people know about Chainlink is its decentralized way to provide off-chain data to smart contracts that require it using its Oracle network. Starting with Chainlink's price pairings, it offers this data to 3 smart contract chains: Avalanche, XDAI, and Ethereum, with Ethereum being the largest, having over 194 different pairings. The value of each pair reported on-chain is known as the trusted value, which is a number built on the mean value of all the reported prices by the oracles, with a minimum number of these oracles being required to confidently say that the value is correct. For example, the BTC USD price pair has 31 oracles, where 21 of these are required to confidently calculate a trusted value. Oracles can report new prices at any time. However, a new trusted value will only be calculated if one of 2 criteria is met. The first criteria is the reported value has deviated by a percentage amount from what is currently held as the trusted value. This percentage amount varies depending on which price pair you're looking at. The second criteria is that it's been an hour since the last trusted price was calculated. Price pairs, however, are only a small part of the Chainlink ecosystem, because at the end of the day, a large enough liquidity pool could do this by relying on arbitrage traders to keep the prices balanced on what the current market is trading at. And while it could be argued that the Chainlink prices are more stable because they do not require these traders to actually balance the price for the pool, they're only useful in select cases. Because of this, along with the price pairs and the verifiable randomness, Chainlink does also provide the ability to make requests to any off-chain web API, or even perform off-chain computation. But before we get into this, we need to go into the 2 methods that Chainlink uses to provide data to smart contracts and the method that it uses to ensure data validity. Aggregation contracts are how the price pairs work, aggregating the value from any number of oracles to ensure the data being provided to smart contracts is correct. Order matching contracts are more like a one-to-one agreement between the oracle and the smart contract requesting the data, where the smart contract will draw up an SLA or service level agreement that outlines what the data requirement is and any stipulations that might go along with it. Then, oracles will bid to be the ones to provide this data to the contract. And as for data validity, this is where the reputation contract comes in. This is used to score each oracle's trustworthiness, using metrics like average response time, number of fulfilled requests, and how much link they have staked to show their commitment in the oracle network. So now, going back to web API requests, due to the vast quantity of information out on the web right now, it would be wholly unfeasible to try and aggregate this data. With price pairs, there is a relative guarantee that the data will be required enough to offset the cost of the extra infrastructure and bandwidth required to aggregate that data. But let's say that a smart contract needs the current weather in Glasgow. This data request would be so sporadic and random that realistically it would be completely unfeasible to try and have it on hand all the time. And this is where order matching comes in. A smart contract will make a request to the Oracle network for the data that it requires, in this case, the weather in Glasgow, and any stipulations that it might need for that data. Then oracles will bid to be the ones to provide that data, either by offering a lower price or being a better fit for the drawn SLA. Now, this does mean that you are trusting a single third party to provide you your data, but I'll go into this later. And finally, we have off-chain computing. Let's say that I want to calculate the MACD of the Tesla stocks over a 1-day interval using AlphaVantage's adapter. This would require calculating the 24-period exponential moving average and then taking it off the 12-period exponential moving average. To calculate the EMA for a 12 or 24-month period, the EMA of the previous period needs to be used to calculate the next period. This means a lot of dataset iteration and computing, which in turn means that doing this on-chain would be prohibitively expensive. So instead, the computation of this data could be written in, say, JavaScript and passed off-chain for computation, and then the result of that computation could be submitted back to the chain in a verifiable manner, therefore reducing gas fees enormously. This is an incredibly simplified breakdown of all of Chainlink's offerings, but of course for everything I've covered there is a far greater depth of knowledge that could be read up on, so I've left links down in the description below for those of you who are interested. Moving on to the Link token, due to the fact the Link token is actually required for data transfer, means there will always be a demand for the token as the node providers will be paid in Link. On top of that, the supply of the Link token is capped, which means the more the network is used, the more demand there is for the Link token itself, but there's not an increasing supply. So in theory, the value should just increase as the network usage grows. However, one critique of supply capped utility tokens is that at a certain point it would become more beneficial just to hold the coins than actually use them, because the price of using the network would be tied to the price of the coin. For example, Ethereum's gas fees wouldn't be nearly so bad if the price of Ethereum wasn't in the thousands. However, Link's solution to this is using a sort of equilibrium to make sure the cost of using the Link network does not rise with the cost of the token. But now we've had the good, it's time for the bad. Firstly, oracles can provide data from any web API as long as they have an adapter for it. However, this data is based on trust. That oracle could give you a completely incorrect value and you would have no way of confirming that it's incorrect on chain. For example, let's say I wanted to know the current temperature on Mars using NASA's API. The oracle could give me any value back and I would have no way of determining its validity. The whole point of decentralized computing is to try and create a trustless and permissionless system. And while I do think that Chainlink's solution to price aggregation is a valid way of getting off-chain data onto the contract, given that it's not just a single data provider that's being used, I think that their solution to web APIs needs some work. Because unfortunately, with more and more money being locked behind these smart contracts, a single data provider being the reason that a smart contract pays out or doesn't pay out money, for example, the ramifications could be massive if that data provider is not providing correct data. Which leads on to my second concern. What if the data is wrong? If the data provided by an order matching contract is incorrect and a smart contract executes an instruction and loses money, how would you actually calculate the accountability and loss of that bad data? It would be almost impossible to actually figure out the accountability and compensation required for an incorrect value being sent on chain. Saying this though, Chainlink has an incredibly strong value proposition, and despite a number of detractors saying that there are better alternatives that are fairer or less centralized, I don't think that there's any competitor that actually stands up to the breadth of services and data that Chainlink can provide in one place. The main selling point of Chainlink is that developers need to learn a single API and make a request to a single network to make their smart contracts work. This is a major benefit in terms of reducing the complexity of actually writing smart contracts. And for this reason, I think that the Chainlink platform is definitely one that should be watched, because as it grows and more data providers become prevalent, the order matching system could be improved to make it a far less trust-based system. So I hope you guys enjoyed the video. If you did, leave me a like and a comment down below. And if you generally enjoy my content, please do consider subscribing. Thanks, bye.